like I always say, welcome back to the bench. Got some good news. My replacement parts have all come in. I'm going to be finished working on this, well, up to a point. I'm going to finish working on this Heathkit VTVM. I'm going to do a separate video on the battery replacement circuit. And I want to get this up, what I've done so far, installing the parts and doing the calibration on it. So with that, let's get going. Okay, so this is the donor VTVM. Like I said yesterday, I thought I was only going to get the meter. He sent me the whole VTVM. So there's going to be some other parts that I harvest on here, but the first thing I'm going to do is work at getting this meter out, because the way they built this, the meter is held in by the 4 screws from the meter, which also holds this bracket in, and you have to get down in there with a little tiny wrench to undo that to get the meter off. So I'm going to work on that, get this meter out of here. You also have to take the 2 nuts off the back, these 2 here, and then the meter will come out the front. So let me work on that. Okay, so this was the bad meter. I've switched the covers. The replacement meter was cracked, which I knew about, was good. So this is the replacement meter now. You can see it's got good meter movement. And I already know that it reads 200 microamps because Rob tested it before he sent it to me. Showed me a picture. So I'm going to keep harvesting. It's crazy stuff, but the little bulb in the bulb holder, harvested that as well. Parts are parts. Sometimes parts are hard to find. Okay, so I'm also harvesting the 10K pot, which is, if you look, it's nice and smooth. It jumps and changes scales. This is auto ranging, but there's no massive jumps. It goes up smoothly. Awesome. Thank you, Rob. Because now I have a 10K pot, which is original to Heathkit. Awesome. Okay, so one of the other things I was talking about was in the AC line for testing on the Heathkit VTVM, there is a 1600 volt 0.01 microfarad capacitor. Okay, I've ordered one because I don't keep them in stock, but the donor still had one in, and I wanted to see the quality of it. So right now, if you watch the eye opening, see how the eye just barely opens? That's not good. And it's opening at, where is it here? At 0.015. I mean, it's not too far off. But with it not opening like that, I'm going to show you what a good one's supposed to look like. Just stand by. I mean, I'm going to also switch this over. And I want to see what now it's supposed to be a 1600 volt capacitor. This obviously doesn't go to 1600 volts, but it will go up to 500. And it keeps opening. We're getting there. We're getting to a point where it's not opening all the way. So that's 500 volts. I mean, it's got leakage. It's not opening all the way at 500. So it should be open like that, the eye. If you see down in here how it's open. Okay, that's normal. It closes as you raise the voltage. As the capacitor charges, it opens back up. But this is never really opening back up. So it's got leakage at a lower voltage than 1600. But I want to show you, I'm not going to do this, I'm not going to take this out of here with this on. I don't want to get zapped. There's probably 500 volts on this cap right now. Okay. Now let me put a good, now this is not a, this is a 600 volt cap, but it's new. Newer. Okay. Turn this back on. Since we're in leakage test, I'm going to leave it in leakage test. Now this is, again, this is a 630 volt cap. Notice how wide this is staying open. Again, this cap's been sitting around for a while, but you can see that how this is staying open, that this cap is still good at 630 volts. Okay, let's turn that down. Let's bring this over to, where are we here? What scale do I want? I want the scale right here. Okay. Now I'm going to bring this up. Watch the eye. Watch how the eye opens. I go past, zero in on it. And if you look over here, it's pretty much right on 0.01. I mean, that's an excellent cap. That's what it's supposed to look like. So I can't use this cap. It's no good. It's electrically leaking. Not that it's leaking liquid like some electrolytics do. They also leak electrically. This is just leaking voltage through the insulating or dielectric materials, and that's what's called leakage in a capacitor. Okay, I'll keep working on. Okay, so I've got the substitute pot that I had in there. I've got that out, and I disconnected the wires. Didn't look where they were going, so now I'm going to have to refer. Now, thank God I got another meter to refer to. This one goes to the bottom, I know that. Goes there. Yeah. I got to get this capacitor out of here too. I'm not going to be able to finish this up because that capacitor's got to come out. Nothing gets thrown away until a job is complete. Doesn't mean it doesn't get lost. Just looking for the nut from the one that came with it, because it's just a little bit cleaner, because it's just a little bit cleaner. So I want to put that on instead. I got to say, if you've, a lot of people think these are only for work, these solder suckers are only for working on printed circuit boards. I got to tell you, when you're working on tube gear and you've got these solder terminals, it just sucks the solder off, makes life a lot easier. This happens to be a ZD985. I talked a little about it in one of my other videos. Let me get this soldered up, and we'll bring you back. Okay, the pot's all soldered into place. Now I have to get all this other stuff back in. I don't know if I'm going to do this online, because it'll probably be scrubbed for saying stuff that shouldn't be said on the air. out of frustration. Okay, so the guy who designed this, I should probably take the tubes out of it too while I'm doing this, so I don't break a tube. These are nice mullered tubes. Yeah, one is anyway. So now, you know, I preach to you guys a lot sometimes about when you're taking something apart, you should always take photos, draw some schematics so that you know where everything goes. Well, you know, sometimes you don't do what you're preaching. And that's what happened with that potentiometer. Unfortunately, I didn't do any of that. I didn't remember where the wires go because they have two white wires. That was something that Heathkit did, and Ico did the same thing. They had the same colored wires. So trying to follow something along was a little frustrating. Let's see if I get this in right here. That can go there. I need my meter. And I've got the original. He put rubber gaskets on here, but I actually have the original two jiggies that go on here. So the replacement meter that Rob sent to me was probably from an older, same model, all the same. But I'm assuming, from what I see, crazy things like the style of capacitor that was used, that red one that I showed you before. Come on, get in there. Beautiful. Okay. That, along with, you know, crazy thing. I'm going to stop for a second, show you this. Here's the two cases. Okay. This was the one that Rob sent. This is metal. The one that I've been working on is plastic handle. So I'm assuming that the metal handle was probably the original, which makes it a little bit older. The screw holes don't quite line up, so I can't change them. I tried that. Yep, there I go. Make you seasick here. Get in here. All right. All right, now comes the fun of putting all this back together. And while this is here, I'm going to take advantage of this not being screwed down so I can get in some of these nuts a little bit easier. It's a little tight, like it's goes on one way and not the other. Okay. Here's another thing. This Exolite toolkit. These are awesome little screwdrivers. I got to go around. This little set here. I Had these since trade school back in the 70s. They got a little power handle you can put on, but it's really nice. The only problem I find with them now is all this Chinesium stuff that comes in. Hey, look, I buy that stuff too sometimes. It's metric. And these are SAE, so that means I can't use them. But it's an excellent little tool set. It'd help if I pick the right size, huh? There we go. And this doesn't go like this because the bracket's got to go on. Talking and not paying attention. Talking and not paying attention. So, where's my tweezers? I don't need my soldering stations on anymore. Yeah, come on. Yeah, I lost a washer. This is where I'm going to turn you guys off because I don't want to say something bad. Okay. I didn't say anything bad. It fell right out. But you can't get in here with a nut driver. Now you got to get in here with a little tiny quarter-inch wrench to try to tighten it up. The guy was a sadist that designed this. Nice meter when it's running. Actually, this is the first Heathkit I've owned. I've got an ICO that I built myself when I was in trade school back in 1973. And okay. Now I got to get this one in there. Okay. My wife asked me why I enjoy doing this. I said, because it relaxes me until I get something like this. All right, it's going to take a bit. This was a bad one. Been having problems with it. Okay, this is the first power up. Let's turn this on. You can see a little, no, maybe you can't. You can see the little lights lit. All that tells you is that the power is on. The meter's starting to work. And we're in AC. So we can zero the meter. DC. It hasn't been calibrated yet. Perfect. All right. So there you go. I have a working meter now. Now I have to build the circuit that replaces the battery. I've already got that. I didn't come up with this, guys. This was a circuit that I found on YouTube from another person. Said he used to work for Heathkit, and in the lab, this is what they built so that they wouldn't have to continually replace batteries on their test equipment. I'm going to sign off on this one and continue to work. I'm not going to post this video until the meter's complete, but as you can see, the meter is now zeroing. I can bring it up to a 0 because there is a need for that, to have a 0, so you can swing one way or the other when you're doing some alignments. And again, I can bring it right down to 0. Beautiful. And this was the 10K pot out of the donor machine that was given to me. It was donated to the channel so that I can complete this. All right, guys, that's it. I'm waiting for some parts to come in. I'm going to be swapping out some resistors. I went through the DC range. I looked at the resistors. A couple of them are out of spec by about 4%. These are supposed to be 1% resistors. They're more, one is 7% out, the other ones are 4% out. Luckily, the ones that are out on my meter are not the ones that were out on the donor meter. So I'm going to be taking 1% resistors from that one and putting them in here on this one. We're getting there, guys. This will be up and running before you know it. Okay, so the parts were just delivered from DigiKey via FedEx. I think it was FedEx. Okay, just going to get this open here. Garbage. Okay, my order. Everything is there. Let's see, 10K pot, which I don't need anymore because I had a donor machine. Yep, 10K pot. Yep. God knows where it was made. Sure as heck wasn't made in the USA. But I'll put this in my stock with pot for pots. Interestingly, I got the resistors. This is a 200K, which I don't need because I had a donor. This is my 1600 volt capacitor, which I'm going to put in. That's going to be my next project. Another resistor, which is a 700K. Actually, it's a 698K, but tolerance-wise, it would have been okay in the unit. Don't need that because I had a donor. My diodes. There's another 6.98 ohm half watt. Again, I had a donor. I don't need that. It was too late though, as well as my 2 meg ohm. But I've got the parts anyway. My diodes I'm going to be using for the yep 1N4007s, 1000 volt 1 amp. These I'm going to use to replace the battery and the cap that goes with it. Nice bags. I use these bags. I save these bags, and when I'm working on radios, I have a lot of parts. I put the parts in and label it, and then when I'm done, I throw the bag out. This way, I keep everything good. Here's my 25 volt, 100. Yeah, what was it? 100 microfarad. 100 microfarad, 25 volt cap. That's also going to be used on that. Little power supply to replace the C battery. All right, so let me get to this. know why I got two, but I got two 1600 volt 0.01s. I think I did that because I've got an ICO that probably needs the same part. So I need that. And we'll get started getting that into place. Now that's going to be interesting. I took a look at this morning in order to get this out, and I did test. Yep, I did test this cap. It's 0.013, which is okay, but again, it's electrically leaky, just like the other one in the other unit. And it's about 350 volts. It's supposed to be 1600 volts, 350 volts. It's electrically leaky. So in order to get it out, I had to remove the switch. I'm going to have to fit it in down here, and it comes over to here. So it's going to be a little bit of surgery. Okay, right down in here, you can see I've got that 1600 volt cap. The wire wasn't long enough to run from one point all the way around to here. So what I did was I attached one solid over here, and then I put an extension wire running around, attached it on. It's the only way I could get it in there, but it's in there solid, and it's right up against the chassis. Nothing will short out on that. Now I'm going to complete the calibration here. I need a puck to hold this so it's not on the, I don't want it on the switch. That should be okay, just like that. All right. All right. Now I'll get ready. I'll get set up. Oops, sorry about that. I'll get set up to do the calibration and be right back. Okay, so I've been talking, didn't have the camera on. Let me go back here. Okay. I have 3.23, 3.22, and we're down to 3.2 and a little bit. Again, accuracy of the meter is 5% at full scale. I'm on the 5 volt scale. I don't have a continually variable power supply hooked up, so it goes in jumps. So this is 4.65, 66. We'll zoom in a little bit on that. And it's close, 4.6. Okay, 4.6. All right, put that up on the 15 volt scale. Again, we're on the top scale now. Excuse the hand shaking. It's about 4.5. I mean, you got to look straight in on the meter. You guys aren't looking straight in on the meter. It's kind of hard to get it with the camera. But yeah, that's very close. This is 6 volts. Okay. 6 volts. Here we are at 7.5. Sometimes analog meters, you gotta give them a little tap, a little love tap. It's 7.5. Again, you're not looking straight in. I have a hard time getting it straight in. Move over a little bit. There you go. That's better. All right. And I want to go down to the 1 volt scale. 1.5 volt scale. Go back down to the 5 volt scale. And I'm on 1.8, 1.78. So 5, 6, 7, 1.5, 6, 7, 8. So the accuracy of the meter is very good on DC. I'm going to reset everything so that I can work on the DC, and we'll bring you guys back in when I'm set back up again. Okay, so for whatever reason, the AC is not reading. I am increasing the voltage. Not sure what's going on. I don't know if it's my test lead, what's going on, but I'm going to have to look into this. Okay, this is going to take a while to investigate and find out what's going on, but the AC does not work on any range. I do have voltage coming into it. I've checked out my cables. Over here, everything is okay going down to my PR57. No idea. There's got to be something could be a bad switch. I'm going to have to get into that, but we will get back to this. Okay, so like I was saying, the AC scale is not working on any range. Checking voltages coming through, coming in, seeing where everything's going. I replaced this capacitor. Did something happen there? Checking voltages up and through here. And I kind of get to here. And on the board, this looks like it's directly connected to the switch, but it's not. And I'm checking the capacitor. I'm not getting any voltage there. Well, lo and behold, this was tucked down in underneath. Didn't see it. You know, these are old parts, old wires. And right in there, it broke off. So let me get this back together. You know, I completely had this unit apart. I've maneuvered it around a bunch of times, and I stressed the wire connection, and it broke. So let me get this back together, and we'll get you back on here so I can do an AC calibration. Okay, got that wire soldered back on, and now I'm going to adjust the calibration for the AC line. I have it set on 150 scale. I'm going to pull my variac up. And I'm still not getting any reading. Amazing. All right, back to the drawing board. Yep, you know what it is, guys? You got to turn the power supply on. There you go. There you go. It's called old age. All right, so let's bring this up to 100 volts. See where we're at. This PR57 is excellent for doing this. Oh. Okay, and we're going to zoom in so we can see. And I got to tell you, I'm looking at this. $100 volts AC. We're on the 150 volt scale, which would be, where's my pointer? Which would be this scale here. Okay, 150 volts. 100 volts. I'm not even going to touch it. Now let's go all the way up on my variac. I can get 100. Yep. I should be able to get 150 out of this. Yeah, slowly creeping up. Yeah. Yeah, close. 150.4. Ah. 150. It's a little over. And you should be adjusting it for full scale. So I'm actually going to give it a little tweak. And where's my little tweaky? I'm kind of trying to look over the yep. Get directly. That's the thing with these meters, you have to be directly. Yeah. Let's see. Bring that all the way down. Yep. I don't think I'm going to get any closer than that, because it's 150, 150. Go back down to 100. That 100's a little off. Interesting. That's doing 98, and I'm right on 100. So that's the accuracy of the meter. 5% of 150 volts is 7.5 volts, if I'm not mistaken. 10% would be 15 volts. So we're talking 2 volts off. That's well within the accuracy of the meter. But let's check it on some other scales too. Let's bring this down to 50 volts. Okay, I'm at 50.3. Oh, I'm still up there. Okay. Again, we're at 40, 47, 46. It's the accuracy of the meter. Let's go to 50 volts. That's way off. I'm not happy with that. I'm not happy with that. I did not change any of the resistors in that network. Well, let's get it. It doesn't get any better than that on 50 volts. I usually don't measure high voltages with these meters anyway. Okay, 50 volts. Let's go down to 25 and see what we got. Oop, went right by it. It gets a little touchy down there. It's 25.25. So it's reading low. Seems like one or more of the resistors in this chain are off. But again, it's still reading within the tolerance of the meter. DC scale is much better. I did change values on some of those. 25, I put it down to I put it up. And we got about 22. It's off by 3 volts. This is the 50-volt scale. Each one of these tick marks would be 1 volt. 25, it's off by basically 1 volt. It's not going to get any better than that. I don't use this to check AC voltage anyway. Calibration is pretty good. It's within the specified tolerance of the meter. So I'm going to let that go. I'm going to wrap this up for now. I'm going to do a separate video on building the little power supply to eliminate the C battery that's in the unit. So with that, remember, click like, subscribe, leave a comment, and thanks for dropping in.